Hey everyone, welcome. Now, if you're feeling a little nervous about tomorrow's exam, I want you to take a deep breath. You are in exactly the right place. I know, staring down a whole semester's worth of material can feel incredibly overwhelming. But tonight I'm going to be your personal tutor. We're going to walk through this explainer together, reviewing Units 3 and 4 of your Prep 2 ICT curriculum. We're going to cover absolutely everything you need to ace that exam tomorrow. I've basically distilled all your textbook summaries into really clear visual points. So just follow along with me, and I promise you'll be completely prepared.
Okay, here's our game plan. We've got 6 quick checkpoints tonight. We'll start with the era of AI, look at AI ethics, peek inside neural networks, jump over to Python data analysis, tackle coding logic and loops, and finish up with cryptography and data security. Let's do this.
Section 1, the era of artificial intelligence. To really understand where AI is heading, we kind of need to look at where it all began.
Check out this timeline. It literally shows the roller coaster history of AI. So it all started back in 1950. Alan Turing asked a really simple question: can machines think? And he invented the Turing test. A few years later, in 1956 at the Dartmouth Conference, the top scientists got together and the actual term artificial intelligence was officially born. But, well, it wasn't all smooth sailing. Look at the 1980s. We hit what's called the AI winter. Computers back then were just too slow, way too expensive, and that initial hype turned into massive disappointment. But don't worry, the story gets better. Fast forward to the 2010s, and boom, we hit the modern revolution. Thanks to deep learning, computers actually started mimicking the human brain, even beating world champions in super complex games.
Okay, listen up, because this is an absolute classic exam question. They are almost certainly going to ask you to contrast artificial intelligence with human intelligence. Here's what you need to remember. AI is all about pure data processing, super speed, and programmed logic. It can process trillions of data points in seconds, which is mind-blowing. But human intelligence, that is where feelings, emotions, empathy, and untraditional problem-solving live. An AI doesn't understand jokes, it doesn't get sarcasm, it can't read a room. That emotional depth, that's our superpower.
And honestly, since AI is processing all this data at those crazy speeds, it brings us right to Section 2, AI ethics and responsibility. Look, AI is an incredibly powerful tool, but with that power comes a huge moral duty. We have to follow some essential rules when we use it. Fairness and transparency, privacy and data protection, avoiding bias, and this is the big one, human supervision. I really want to stress this point. Humans must remain the ultimate decision makers in critical fields. I'm talking medical diagnoses, judicial rulings, national security. Why? Well, going back to what we just talked about, AI lacks true awareness. It has no ethics, no empathy. A machine should never be the final word on someone's life or liberty.
Now let's look at how the problem of bias actually happens. As you can see from this diagram, straight from your textbook, if an AI system learns from unfair or incomplete patterns, what we call biased data, the output is naturally going to be a biased AI. It's the classic rule of programming: garbage in, garbage out. Developers absolutely have to use high-quality, diverse data to train these systems. If they don't, the AI just ends up repeating our own human prejudices.
So we keep talking about AI learning, but how does it actually do that? Let's shift gears and look under the hood in Section 3, inside artificial neural networks.
To make computers learn, scientists literally try to imitate how our human brains work by creating artificial neurons. To build one, you need to memorize these 5 exact steps. Step 1, identify your input data, like an image or a sound clip. Step 2, give a weight to each input. This just tells the system how important that piece of data is. Step 3, multiply those inputs by their weights and add a bias number to adjust the final result, making it a bit more flexible. Step 4, send it to the activation function. Put a big star next to this in your notes. The activation function is the decision maker. It decides if the artificial cell should fire up or not. And finally, step 5, you get your final output.
Let's ground those 5 steps in reality with this example. Notice how the image of the cat enters the system as the input? The neuron then analyzes all the pixels using those weights we talked about. All that heavy math happens right there in the processing center. And then it hits that question mark. That's our activation function. The function looks at the math and makes the final call, sending out the signal, yes, it's a cat, or no, it's not a cat. And the crazy thing is, when you connect thousands of these simple neurons together, you get a neural network that can literally drive a car.
All right, now that we've conquered AI theory, let's transition into some practical coding. Section 4, Python Data Analysis Basics. Python is the go-to language for this stuff because it has these amazing built-in libraries.
If your exam asks you how to find an average in Python, here is your exact answer. Look at line 1. Import numpy as NP. You always have to bring the library into your script first. Line 2. We define our data inside brackets. Now line 3 is where the magic happens. Mean equals np.meanData. That tiny, simple piece of code does all the heavy mathematical lifting for you. And line 4, it just prints the result to the screen. It's simple, it's elegant, and it is highly, highly testable.
Now, what if you're handling spreadsheets? For that, we use the pandas library. Notice how import pandas as PD gets the library ready to go. Then we use df equals pd.readExcel grades.xlsx. That specific readExcel function is literally what loads your file into the program. And hey, make sure you remember this next part for tomorrow. Print df.head does not print the whole file. It only displays the very first 5 rows. Don't let them trick you on that.
Okay, let's keep this coding momentum going. Moving on to section 5, coding logic and loops. This is the core programming logic you absolutely need locked in your brain.
You will definitely 100% be tested on the difference between these two loops. Use a for loop when you know the exact number of times you want to repeat something, like for I in range 5. Easy, right? But the while loop repeats code as long as a certain condition remains true. Now here is a massive warning for you directly from your textbook. If you write a while loop, you must include an increment, something like x plus equals 1 at the bottom of the loop. If you forget that step, the condition never changes and you create an infinite loop that will crash your entire program. You definitely don't want that happening on your test.
Before we leave Python behind, I want you to take a mental snapshot of this table. It is the ultimate cheat sheet for data structures. The brackets are the most important part to memorize here. Lists use square brackets, and their data can be changed or modified. Tuples use regular parentheses, and they are fixed or constant. Think things that don't change, like days of the week. Finally, dictionaries use curly braces, and they rely on key value pairs, which is perfect for something like looking up student records. Get those brackets memorized.
We're almost there. We've processed data with AI, we've analyzed it with Python, but how do we keep it all safe? That brings us to our final unit, Section 6, Cryptography and Data Security.
Let me ask you a quick question to get us focused for this final stretch. Think about when you send a private text message. How do apps like WhatsApp keep your messages safe from hackers who might be trying to intercept your data over a public Wi-Fi network?
The answer is cryptography. And here's the exact, definitive definition you should write down if they ask you tomorrow. Cryptography is the art of converting readable data, which we call plain text, into an unreadable form, which we call ciphertext. Basically, it ensures that even if someone manages to steal your data file, it just looks like absolute gibberish to them.
Now, there are a bunch of different ways to encrypt this data. Let's contrast a really simple method with a super complex one. The Caesar cipher is a basic encryption method that just mathematically shifts letters by a specific number, like turning every A into a D. It's a fun puzzle, but honestly, it's pretty easily broken. On the completely other end of the spectrum, we have AES encryption. AES uses incredibly complex mathematical equations and really long digital keys, which is exactly why it's the gold standard used by major banks and giant corporations all around the world today.
To pull off this kind of professional, high-level encryption, computers use what are called bitwise operations. Notice this XOR operator on the screen, represented by that little caret symbol X. It has this brilliant reversible secret. It's so cool. If you take your plain message and apply the XOR key to it, it scrambles into unreadable ciphertext. But to decrypt it, you literally just apply that exact same key a second time, and your original message pops right back out. It is lightning fast, it's professional, and it's just mathematically elegant.
And just like that, guys, we've reached the end. We have officially reviewed the entire syllabus for Units 3 and 4. Think about what you know now. You understand the roller coaster history of AI, the moral ethics of data, the math behind neural networks, the basics of Python coding, and the hidden secrets of cryptography. You are completely equipped and you are totally ready to succeed. So tonight, get a good night's sleep, trust your memory, and remember everything we covered today. You've got this, for sure. Good luck on the exam tomorrow. And honestly, as you're sitting there writing your answers, ask yourself, with AI processing data faster than ever before and cryptography guarding our deepest secrets, what role are you going to play in shaping our digital future?